production value. Okay. So, you guys are lucky you came, because as I was preparing this lecture, I realized that this is kind of on the hard side. So this is like maybe, I don't want to overhype it, but it might be like the hardest thing we do this semester. I think this is a topic where students have a fair amount of trouble. So it's not ideal that we didn't have a standard lecture for it, but I'm glad you guys could make it to chat about this. Okay, so the idea of what I want to do is the underlying concepts are very similar to the song and dance we did on Tuesday, right? With the kind of iteratively reasoning through what should the consumer buy next to maximize their utility, but it's with a more formal model. And so I'll introduce there are kind of two components to the model, and I'll tell you what they are, and we'll talk through them. Then we'll put the two components together and find the solutions, and then we'll do some analyses based on those solutions. Okay, so two components to the model. First one is called the budget constraint. The budget constraint is what it sounds like. It's the part of the model where we account for the fact that the consumer faces prices, and that the consumer has limited income. Yeah?
Not sure that's like on the camera.
No?
No, it's not.
Big save, thank you.
Should we like put it back here?
No, because I want you to be able to hear me. Like the microphone's pretty good, but not great. I just need to fine tune here a tiny bit. And there won't be much action at the top. Okay, this is gonna be a great video. I mean, Khan Academy level video. Okay, I think it's on there now. Thank you. So yeah, the budget constraint. For example, let's say a consumer has an income of $100, and they're choosing to consume either coffee or donuts or some combination of the two. That'll be the hokey example I use throughout this lecture. And let's say the price of coffee is what do I want to say? Say the price of coffee is like $4, and the price of donuts is like $2 or something. Yeah. And then what the budget constraint is a graph with one good on the vertical axis and another good on the horizontal axis. So I'll put coffee up here and donuts down here. And it's going to define the set of combinations of coffee and donuts that the consumer could afford. Yeah, so that's why it's called the budget constraint. Yeah. So if the consumer spent all their money on coffee, how many coffees could they buy? 25, not a trick question, right? So 25. And the way you got that was by saying 100 divided by 4. Right? They have $100 to spend. Coffees are $4 each. They could buy 25 of them. Conversely, if they bought all donuts, they could buy like 50 donuts. Yeah. And the way we got that is 100 divided by 2. And then they could buy any linear combination of those two. Yeah. So I'll draw a straight line between the two. And this is the set of all points that are feasible for the consumer to choose. Yeah. So for example, they probably wouldn't buy all coffee or all donuts, as we'll get to, but they could, for example, buy 10 coffees, spending $40, have $60 remaining, which they could use to buy 30 donuts or something. Yeah. Okay. It would be great if they could consume this point. Yeah, lots of coffee and lots of donuts, but they can't afford it. Right? So anything outside of the budget constraint is infeasible. Yeah. On the other hand, they could afford this, right? Like, less than 20, they could afford 10 and 10, for example. Yeah. But in this model, at least, they never will, because they're going to maximize their utility, and they like coffee and donuts, and there's no saving or anything in this kind of simple introductory version. So they could, in principle, consume on the interior of the budget constraint, but they never will. Yeah. Because I would leave them with money left over, and they'd be happier spending that money. Yeah. So the consumer's going to choose a bundle somewhere along the budget constraint. Okay, that's the budget constraint. This won't seem very important now, but it'll turn out to be useful momentarily, is to characterize the slope of the budget constraint in terms of relative prices of the two goods. Yeah? Which is why I wrote these 100 over 4 and 100 over 2 up here. So the slope of the budget constraint is like any other slope. It's the rise over the run or something, right? The rise in this case, you could write it as 25 or 100 over 4. Yeah? So let's see, I'll say slope of the budget constraint is equal to the rise, which I'll write as 100 over 4. Yeah? Divided by the runs, this horizontal distance, yeah, which I'll write as 100 over 2. The reason I wrote them that way is so I could do the following rearrangement. I could, flip the denominator here, so they could rewrite this as 100 over 4 times 2 over 100. The 100s cancel. You're left with 2 over 4. And that's the slope of the budget constraint. Technically, the slope of the budget constraint is negative 2 over 4. Yeah. Okay, note that that is the price of donuts divided by the price of coffee. Yeah? For, I think, obvious reasons when you write it all out this way. Yeah? So in general, the slope of the budget constraint is the inverse of the price ratio. Yeah? It's the price of the good on the horizontal axis divided by the price of the good on the vertical axis. Or, because this thing's negative sloping, the negative of that, but I'll leave it in those terms for now. Yeah? Okay, so the budget constraint, the slope of the budget constraint, which is written by this term, tells us the rate at which the consumer can trade off coffee for donuts, given their prices. Yeah? If they want to buy, if they want to buy one more coffee, they have to give up half a donut. Or if they want to buy one more donut, they have to give up half a coffee. Yeah? So it tells us the rate at which they can trade off one for the other, given prices. Yeah? Okay, that's the budget constraint. It's the first substantive part of the model. The second, and maybe hopefully slightly more interesting or new part, is how we're going to represent the consumer's preferences. Yeah. So in the tedious numerical examples we did last lecture, we knew something about the prices the consumer faced and their income, but we also had to know, like, hey, how much do you like tacos and how much do you like Coca-Colas? We needed to characterize their preferences somehow. Yeah. And we did that with the utility function last time, the main characteristic of which was that there was diminishing marginal utility. Yeah. So this is like conceptually similar, but just a different sort of way of modeling that. Yeah. So you start with the same axes. We'll put coffee up here, and donuts down here. Okay, and then every point in the plane, right, represents like a bundle of coffee and donuts. Yeah, so right, just like it did in the budget constraint world. So consider some bundle A. Yeah, and that bundle A, the consumer consumes this many coffees and like this many donuts. And I'll extend these for reasons that'll be obvious in a moment. Okay. And we want to know how much the consumer likes coffee and how much they like donuts relative to each other. I want to say something about their preferences. So here's a question. Would the consumer prefer bundle A or bundle B? Or can't we say?
Say B, because you get more of both.
You get more of both. Yeah, so bundle B is clearly superior to bundle A, as long as coffee and donuts are goods, right? As long as the consumer likes them. Yeah, and we'll assume that they are. Both because coffee and donuts are delicious, and because if they didn't like them, they would just throw them away or something. Yeah. Okay, and similarly, if you had some bundle down here, right, that had less coffee and less donuts than bundle A, it would clearly be inferior to bundle A. Yeah. Okay, less trivially, consider some bundle over here, bundle C. Yeah. What does the consumer prefer? Bundle A, bundle C, or can't we say? Yeah. Now the consumer has some trade-off, right? Because relative to bundle A, bundle C has more coffee, which is good, but it's got fewer donuts, which is bad. Yeah? So it's it's not clear whether the consumer will prefer A or C to each other. And similarly, if you had something down here, it's like, well, that's got a lot of donuts, which is good, but relatively little coffee, which is bad. And how does the consumer kind of weigh coffee and donuts in their happiness? Yeah. Okay, so if that makes sense, let's introduce the actual thing of an indifference curve. So an indifference curve, which I'll draw with this shape almost always, kind of convex to the origin. An indifference curve is a set of points, right? So like a set of bundles, such that by construction the consumer is indifferent between them. Yeah, and that's why it's called an indifference curve. So another way to say that is like for all the points along a given indifference curve, the same level of utility is achieved. Yeah, so I could label this one as like, U equals 20 or something, which is to say any combination of coffee and donuts that falls on this curve gives the consumer a utility level of 20. Yeah. So if I ask the consumer like, hey, would you rather have bundle A or bundle B or bundle C? They're like, well,